Welcome everybody to a new video. In this video I'll introduce you to the basic of electronics. So I'll explain you how electricity works and how a voltage generator works. So if you're starting to study electronics, this video may be very useful for you. Before I begin, I would like to tell you that if you like my videos, you could consider the idea to give me a like or subscribe to my channel, or both, why not? Also, in this channel I make videos in Italian and Spanish too, so if you are searching for English only videos, you just have to look in the playlist and there you'll find all the English videos. Well, let's begin. So, electricity. We all know that it is very useful, it can be used for really a lot of things, but okay, how does it work and what it is? Well, to understand electricity, we have to go back and imagine atoms. Do you remember how atoms are done? Well, atoms, they have a core, and this core is made by protons and neutrons. And then around this core, we have electrons orbiting around it. It could be 1 electron, or 2 electrons, or 3 electrons. It doesn't matter, but we have a core made by protons and neutrons, and then electrons orbiting around it, okay? Okay, now let's forget about the core. Let's forget about protons and neutrons. We don't need them. Let's just think about electrons. Okay, imagine electrons. Imagine they move from one place to another. Electrons will move from one place to another. Okay, this is electricity. Basically just this. Electricity is a flow of electrons. But now we have another question. Why they move? What is the reason why they move? Well, to understand this, we have to keep in mind this principle, the difference of potential or the potential difference. Two different terms here, but we are talking about the same things. I could call it in this way or in this way. It's the same thing. So, what is the difference of potential or the potential difference, if you prefer? It is very simple, actually. We have to understand that all atoms, they could be positively charged or negatively charged, okay? And since all atoms could do this, think about it. All matter is done by atoms, okay? So if atoms could be positively charged or negatively charged, this means that all matter could be positively charged or negatively charged, okay? I hope this is clear. Then let's forget for a moment about positive and negative charge. Let's just think about charge, like if it is an amount of charge. Let's just think about charge. So, all matter could have a certain amount of charge. And let's imagine I have two different pieces of matter, one and the second one. I have two different pieces of matter, and these two different pieces of matter, they got a different amount of charge, okay? So till they are not in contact, nothing really happens. They just have a difference of potential, okay? Because they have a different charge. So till they are not in contact, nothing happens, but what happens when I put them in contact? Well, what happens now is that the charge is like their charges, they just go together. It is like, now it is a total amount of charge, and this total amount of charge, which is the charge contained in both of them, it distributes into both of them till they both have the same amount of charge, okay? And the difference of potential does not exist anymore, because they now have the same amount of charge. I know maybe in this way it could be not so clear, but let's make an example to make it very, very clearer. It will be very easy to it will be very, what the heck? It will be very easy to understand it with this example, with this practical example. Let's imagine two vases full of water. Okay, the first vase here. I have the first vase here. I apologize because I'm not really good at drawing. But I have the first vase here, and it is full of water till this level. And another vase here, which is full of water till maybe this level, okay? So I have these two vases, they are full of water, but this one is full of water till this level, full enough. And this other one just have a little of water, you know, just this water. Okay, now till they are not in contact, nothing really happen. They are separated, okay, but they have, you can see they have a difference of water level. They have a difference of potential. And what happens now if I snap my finger? No, I don't like that. No, this way. Okay, what happens if I snap my finger and magically a pipe appears here? Now we have a pipe who connects these two vases of water. So water now can flow from here to here or can flow from here to here. They are connected, okay? And what happens now? They are connected, so what happens? Well, what will happen now is that the water contained here will flow in this other vase, because here we have less water. So water will flow from here to here. And water level here will rise up, maybe till this level, okay? This doesn't exist anymore. So water level will rise up till this level, and here, since some water goes here, the water level here will go down till this level. And when they reach the same water level, water will stop flowing. Okay, this is clear enough. Very simple to understand. And that's the same thing that happened with charge. With charge, basically we have this same thing. Probably you remember when you step out from your car, okay, and maybe you touch your car and there is a little spark of electricity. You touch your car and you have a little spark of electricity. Well, in that moment, what really happens is that you add a different charge, a difference of potential between you and your car. And in that moment, when there is that little spark of electricity, this difference of potential equilibrated. So the charge in your car, you have exchanged, okay, some charge between you and your car. And after the spark of electricity, there is no more difference of potential. So this is what happened. Okay, now let's try to learn another important concept. So I have these two vases, and we already know they are full of water, this one till this level, and this other one till this level. Then there is a pipe connecting them. And what will happen here is that water will flow from here to here. So now imagine I remove a piece of plastic or a piece of glass here from this pipe. Imagine I could do this. I remove a piece of glass here and I install a wheel here, like a wooden mill. So I install this wheel here, made in this way, maybe. And what will happen? So while water will flow from here to here, this wheel will rotate, but this wheel will stop rotating exactly when water will reach the same level in both vases. There is no more water movement and wheel will stop rotating. Okay. Imagine I want this wheel to keep rotating. What I could do? There is something I could do to allow this. Imagine there is a guy here which is holding a great cup of tea. Just a cup, it's not full of tea, just a cup. There is a guy here holding a cup, okay? This one is the guy holding a cup. A weird guy, but he's holding a cup. Okay, so this guy is holding this cup. What is he doing? Is taking water from this vase and putting it in this other vase constantly. Takes water from this vase and put it in this other vase. It takes water from this vase and put this water in this other vase. Take water from here and put it here. In this way, what is this person doing is keeping this difference of potential existing is keeping this difference of potential alive. Until it keeps this difference of potential alive, taking water from here and putting it here, water will keep moving in this way, okay? So, what this guy is doing is very similar to the function of a generator. This guy, or this person, doesn't really look like a guy, this being, what this person is a generator. So that's what a generator does. I always mistake sometimes the verbs. I forget to put the s in the third person. This happens very often. Okay, but now we have understood what is the difference of potential and what is a generator. Now we have both this concept. And I hope it is clear enough. I hope this explanation is clear enough. This example could be, I think these examples are easier to understand than talking about just electricity. And that's the same thing that happens with charge. Basically, imagine I have two pieces of matter, this one and this other one. This piece of matter has an amount of charge. Let's just talk about amount of charge, not positive or negative. This piece of matter has +5 charge, and this other piece of matter has +1. I put them in contact with a wire, and now the charge will flow from here to here, will distribute till they have the same amount of charge, like +3 and +3 here too. So they now have the same amount of charge, and charge doesn't distribute anymore because there is no more difference of potential. But now let's introduce the concept of positive charge and negative charge, because this will be very important to understand electricity. So imagine a random atom from a random material. It doesn't matter what kind of atom it is, just a random atom. And imagine these atoms got a core, which is made by 2 neutrons and 2 protons, and then 2 electrons orbiting around it. So we have a random atom from a random material, which is made by a core, made by 2 neutrons and 2 protons, and 2 electrons orbiting around the core, okay? This is how this random atom normally should be, okay? So, in its normal form, this random atom got 2 neutrons, 2 protons, and 2 electrons. This is its normal form. But what could happen is that these atoms could eventually lose an electron. And when an atom loses an electron, this is what happens. We have the same atom as before, but now we have these electrons and an empty space here. And when an atom loses an electron, we can say that an atom with less electrons than how many there should normally be there is positively charged. Okay, so an atom positively charged is an atom with less electrons than how many there should normally be. Okay. What could happen also is that these atoms, these random atoms, could eventually gain an electron more. And when an atom gains an electron more, or more electrons more, this is what happens. Okay, we have the same atom as before, but now we have 3 electrons orbiting around it. And we can say that an atom with more electrons than how many there should normally be there is negatively charged. So now we know what does it mean to be positively charged or negatively charged. Obviously, I made the example here of just losing an electron and gaining 1 electron, but an atom can gain 2, 3 electrons or lose 1, 2, 3 electrons. This was just an example, because it was much simple to make an example just with 1 lose, 1 gain, okay? So if I have 2 atoms, one is positively charged and the other one is negatively charged, what happens if I put these 2 atoms close enough together? What will happen is that an electron here, an electron in surplus here, will flow to these other atoms and will go fill this empty space. So an electron will flow from here to here, going to fill this empty space. And this is how the flow of electrons occurs. This is how the flow of electrons happens. And when these two atoms, when these electrons has gone here, we don't have any movement of electrons anymore. The difference of potential has been filled up, has been solved, okay? So exactly like in the water basis example, if we compare electrons to water, we could see the same situation happening here. The surplus here, the excess here, will just move to this other place. In the water basis example, water flows from the vase with more water to the vase with less water. And here, the same happens. We have an atom with 3 electrons here and an atom with 1 electron and an empty space. Okay, so the electron in excess here just flow to these other atoms. And when they both have the same potential, well, both have the same number of atoms, everything just stop moving. But this is not exactly like the water vases example. There are some really important differences. To have this movement of electrons here, I need to have on one side an atom with less electrons than its normal form, and on the other side an atom with more electrons than its normal form. I need this imbalance on both sides. If I would have, as an example, here an atom with the right amount of electrons, okay, just a normal atom with its normal amount of electrons here, and here an atom with more electrons than its normal form, I will not have this movement of electrons, because I need more electrons on one side and less electrons than its normal form on the other side, because I need some empty space to fill with electrons, okay? While in water vases example, this is not the case. In water vases example, I just need these two vases, and if there is a bit more water on one vase, water will just flow. I just need this. Also, there is another thing that maybe we haven't noticed at the first sight, but if we look at it, this atom is positively charged and this other one is negatively charged. And an electron moves from the negative side to the positive side. Okay, so we have this movement of electrons from negative to positive. And this is very different from what we are usually used to think. When we think about electric circuits, we imagine current flowing from positive to negative. But in reality, we could see that that's not what really happened. That's exactly the opposite. This is a generator. This is how usually a generator is drawn when you want to draw electric circuits. There are also other representations, but this is usually the representation of a voltage generator. The longer line represents the positive, the shorter line represents the negative side. And if I want to maybe use an electric bulb, imagine I want to use an electric bulb, a light bulb, here. I apologize again, not really good at drawing. Okay, minus, plus. Okay, we are used to think that electricity moves in this way from positive to negative, okay? We are used to think electricity moving in this way. But in reality, what we have is a movement of electrons in these other ways. But why all circuits are represented in this way, with current going from positive to negative? Well, this is the classic representation. Some times ago, well, really a lot of times ago, the earliest person who studied this kind of things, they believed that electricity moves from positive to negative. They believed this. Recently, they discovered that that's not the case. It's actually the opposite. Electrons moves from negative to positive. But why we still use this representation when we draw electric circuits? Well, because this representation actually works, and it's we could say it's easier to calculate all the currents and to imagine the circuit in this way, even if it's not true, but it works to calculate everything you need to calculate. So if it works, why not keep using it? Also, the positive side seems to be the active part. Even if electrons flows from negative to positive, the positive side seems to be the active one. Imagine we have two cables here, two cables to three cables, and another cables here. Okay, don't touch any cables. If you see three cables, never touch cables, okay? But imagine we have a generator and two free cables here. Well, usually, don't do it anyway, never do it, but usually if you touch the negative, nothing really happens, because it is not the negative who pushes electrons outside of it. Even if electrons goes from negative to positive, it's not the negative who pushes electrons outside of it. It seems more like positive is the one who pulls electrons, okay, to its way. So positive is still the active part. Even if electrons goes from negative to positive, positive seems to be the active part who pulls electrons, okay, on its way. So what happens if you, as an example, if a person touches this, the positive cable? If a person touches this positive cable, okay, this is a weird person as always. If this person touches the positive cable, and there is the ground here, there will be a flow of electricity. Okay, we are used to think that electricity will flow from here to here, to the ground, through this person, and this person will unfortunately take current, okay? So we are used to think it this way, that electricity will flow from here, from the cable, through the person, and will go on and will discharge on the ground, okay? But what really happens is that there will be a flow of electrons. If this person touches the cable, there will be a flow of electrons from the ground through the person going here. Okay, so there will be a flow of electrons in this way if this person touches the cable. So a flow of electrons from the ground through this person to here, to the positive side of this generator, to this cable, basically. Anyway, never touch any cable again, never do it. And this is only possible to have this flow of electron to catch current. It is only possible if this person touch the ground. Theoretically speaking, if this person does not touch the ground, imagine this person is flying, and there is some space between him and the ground. This person is flying, and they touch the cable. Well, theoretically speaking, they could not catch current, because if this person does not touch the ground, we could not have this flow of electrons, okay, because this person is not connected to the ground, so we could not have this flow of electrons. Exactly like the vases without a pipe connecting them. But when the difference of potential is really, really high, when the difference of potential is enormously high, what could happen is that this exchange of electrons will happen anyways. And we have a clear example of this. When there is a storm, you got some clouds in the sky. These are clouds, okay? We have clouds in the sky, and there is the ground here. The ground and the clouds are very, very distant, but the difference of potential is so high, is so great, that this exchange of electrons will happen anyway, even if there is a great distance, because the difference of potential between here and here is enormously high. So we have this phenomenon. What is this? This is a, how do you call it? A lightning. Maybe I think it's a lightning. We have a lightning here. This lightning basically is a flow of electrons. This lightning is a flow of electrons, okay? To feel this difference of potential. And what we see is the lightning moving from the cloud to the ground. This is what we see with our eyes. This is what it seems to us. But in reality, the flow of electrons goes from the ground to the clouds. This is the flow of electrons direction, because the ground is negative, and here on the clouds we have a positive situation. Okay, so this is the direction of the flow of electrons, but what we see is the lightning going from the cloud to the ground. Let me explain you another thing. Current, in order to work, in order to flow, it needs a place where to start and a place where to end. Or it needs to go and come back. Otherwise, it cannot work, it cannot flow. What does it mean? Let me explain you with an example. This is a voltage generator. We already know what it is, what it does, how does it work. Okay, here there is the positive side and here there is a negative side. Now let's connect the positive side of this generator with a wire to an electric light bulb. Okay, so what will happen now? In our imagination, probably, we could think that current will flow from here to here and the light will turn on. But in reality, this is not what will happen. In reality here, nothing will really happen in this situation. Why? Because current cannot circulate. And why? Okay. This situation is very similar to this other situation. Do you remember the example of the person who is touching a cable? Again, never touch the cable. If you see an exposed cable, never touch cables. This is just an example. But this person, imagine this person is touching this cable with an hand. And they are touching the cable, but this person is not touching the ground. It's like a superhero, something like that. He's flying. So he's flying, he's touching a cable, but he's not touching the ground. Well, in this case, this person cannot catch current. Why? Because it's not touching the ground. And why cannot catch current if they don't touch the ground? Why? Well, because actually in the classic representation, current can go from here to here, but doesn't have a place to where to discharge. Okay? So, if this person doesn't touch the ground, they cannot catch current. Okay. In the real representation, not the classic one, electrons should flow from the ground through the person in there, in this positive cable. But still, this can't happen if this person doesn't touch the ground, if this person is flying in the air. Okay. Again, this is just an example. Never touch cables. This is a superhero, not a normal person. You are not a superhero, so never touch cables. Remember, never. Never do this. Okay. But this person in this example doesn't catch current. Okay. But we want this light bulb. In this other example, we want this light bulb to turn on. And what could we do to make it turn on? Well, we just need, we can do it in two different ways. The first one will be taking another wire and connect it to the negative side of the generation. In this case, current can flow in this way through the lamp and then going back. So in this case, the current begins here, flow in this direction, goes inside the lamp, and then come back to the negative side of the generator. So in this case, the lamp can turn on. Another possible example would be this. Generator, light bulb. Okay, I take a wire from here and connect it to the light bulb, and then another wire and connect it to a place where it can discharge current. This symbol symbolizes the ground, or basically this is a neutral or negative place where current can discharge. Okay, in this case current can flow. Okay, in this case current can flow and discharge, so I can have a flow of current in this case. So basically I need this, a place to start and a place to where to end, or I need to go, arrive to the place and then come back. Okay, I need this. If a circuit doesn't have this, it is called an open circuit, like this, a generator, maybe here. Okay, this is an open circuit and current cannot circulate in these cases. Okay, I can have a very high voltage, like 300 volts here, but current cannot circulate anyway because it is an open circuit. Current needs to go and come back, or to go and discharge somewhere. Okay, this way current cannot circulate. Maybe I'll tell you one last thing. Okay, when you have that things, that things that goes in the wall, they are done in this way in here in my country. In your country they are probably different, but that things that you put in the wall. Okay, and then they go to something, maybe they go to turn a light bulb on or something else, I don't know. Okay, it looks like it is just one cable here. You put the cable here, okay, and this starts on. But in reality, inside this great cable, there are two or more cables. The positive one goes there and the negative one comes back. Okay, so there is the positive one who arrives here and the negative one who comes back. There is even a third cable. This is the ground and this is like an emergency thing, but we don't know to talk about this now. For now it's not necessary to talk about this now. Okay, so I think for this first video is enough. I hope you understood enough well. I hope you understood enough what I explained. I know that English is not my language, so probably my English is not perfect, but I hope everything was clear enough. If you have any question, feel free to ask me in the comments. I'll do everything possible to answer. Don't worry, I can understand perfectly. I know when I speak, my English is not excellent, I know, but if it is about reading and writing, don't worry. I can understand everything. Even a person who talks to me, I can understand everything they say, but when I talk, I'm a little... Anyway, for this video, I think this is enough, and yes. I already said, if you have any question, okay, so see you in the next video. Bye.